Now we're going to look at power functions with rational exponents. A power with a rational exponent is only defined for positive or at least non-negative numbers, which means power functions with rational exponents, the x has to be non-negative, so the result will also be non-negative, so they will be only placed in the first quadrant. Here we see the exponent q being 4.9, so larger than 1. We have half a parabola, and now we let the q get smaller and smaller, and we see the parabola becomes flatter and flatter. When q is 1, what we get is just a straight line, namely y equals x to the power of 1, so y equals x, which is the angular bisector. When now q becomes smaller, between 0 and 1, we get a root function, as we know. Now if q is 0, what happens then? We have y equals x to the power of 0, which means y equals 1. So we get the horizontal line going through the point 0, 1. If the exponent is negative, then we get a hyperbola. So let us complete this in our script. When q is larger than 1, is this case here, which means we get half a standing parabola. For q equals 1, we have this here, y equals x, so we get the first angular bisector, the erste Winkelhalbierende. And if q is between 0 and 1, here we have these root functions, which means we get half a lying parabola. For q equals 0, we have y equals x to the power of 0, so y equals 1, so we get a horizontal line. And if q is smaller than 0, what we get is here a hyperbola.